Okay, good morning students. Today we shall see the demo of the one more experiment in your hardware part, that is astable and monostable multi-vibrator. So here we have the experiment in order to design and test the astable and monostable multi-vibrator for a given specification using 555 timer. Okay, so the timer, I'll give some explanation regarding this. Okay, the timer IC is an integrated circuit which is implementing a variety of timing and multi-vibrator applications. Okay, so this 555 timer has a 3 operating modes, that is monostable mode, astable mode, bistable mode, or a Smith trigger we can say. So in your lab you have this monostable and astable mode. So in the monostable, in this mode the 555 functions as a one shot, that is applications includes under this will be timers, receiving pulse detection, the bounce free switches, okay, and the touch switches. Like this we have a lot of application under this monostable mode. So astable mode means it is a free running mode. Okay, so the 555 timer can operate as an oscillator, uses its LED and lamp flashes, pulse generation, logic clocks. These are some application under this astable. Okay, now we shall see the first monostable mode. So in the monostable mode we have we are designing to a two design part. One design part which is greater than, here we can see this is a design part where the duty cycle is greater than 50%. Okay, and this is a schematic for this, and also these are the waveforms for this astable multivibrator. Okay, so the design will be so in order to design the astable multivibrator using 555 timer for frequency about 1 kilohertz, duty cycle equals to 70%, and V out will be 5 volt. Okay, so they are designing the T1 for 0.69 into RA plus RB into C, and T2 will be 0.69 RA into C. For that they are going to find out the duty cycle. So we are getting the duty cycle as 70%. Okay, again for that we are getting the resistance values as RA 1.3 kilohertz and RB 1 kilohertz. Okay, and as well as we need to find the capacitor's value. So from these specifications we are getting this capacitor's value as a 0.4 microfarad. Okay, using these design specifications and this circuit diagram, we have this circuit diagram for this. Okay, so since it is a 70% duty cycle, so this is a duty cycle circuit diagram where it is greater than 50%. So we are having this RA, RB, C values here. So I have done the circuit here. So circuit is rigged as per the circuit diagram shown in your manual. So we have this 555 timer. We have this 555 timer, and these are the values RA and RB, and for a point this resistance, this capacitance, I have taken the DCB here. Okay, so I have set it for 0.4, 1, 2, 3, 4, 0.4 microfarad, and here 0.1. Okay, so here this is a 0.1 microfarad, and this is a circuit arrangement for the astable multivibrator for duty cycle which is greater than 50%. Okay, and as well as we are going to take a supply for this VCC. So here 4.4 pin and 8th pin is shorted and is taken to here. This is a 4th pin and 8th pin, and this is given to the fixed supply 5 volt as well as ground. Okay, so the circuit is rigged as shown in your lab record. So now we shall see the readings of this. So one, we need to take the output near the 3rd pin. Okay, so we are getting this square wave near the third pin. When you are taking the output across this capacitor, okay, this capacitor, we are getting this charging and discharging of this capacitor. Okay, so first we shall switch on the power supply. Okay, so as of now I have connected to the third pin of the circuit. So I am getting the square waveform. Okay, so this is the first output V0, and we need to get the readings for charging and discharging. So now I am taking this and I am connecting across the capacitor. Okay, here I have used a capacitor 0.4 microfarad. That is, across this capacitor we need to check the reading. Okay, so this is a waveform we are getting for the when you are taking across the capacitor. Okay, so now we shall check the readings for this. So this is a design for a duty cycle which is greater than 70%. Okay, and VCC we are giving as a 5 volt RA RB C value. Okay, so first we need to check the T on T off value here. Okay, so what is T on T off means? In the circuit, okay, if it is the waveform, you are getting a waveform of capacitor like this. Okay, so if you look into this waveforms, we get to know that is this is a square wave we saw. This is for third pin and this is across the capacitor. So here from this to this we are getting the T1 value. Okay, and the discharging part will gives the T2 value, that is T on T off. This is also T on T off value. Both are same, we can say. So let me check with this. So what is the T on value here? So if you take one reference point, okay, this is a charging point. Okay, that is here, this to this is a charging point, we can say, this to this. So what is the value? 1, we can say, from this peak point to here we have 1 into, we are taking the time. So here time division we need to multiply, that is 0.5. Okay, so same thing I am taking here, that is 1 into 0.5 milliseconds. So we are getting T on as a 0.5 milliseconds. Okay, next we need to take value for T off. So what is T off? Here from this to this, that is 0.2, 0.4, 0.6. Okay, so what is 0.6 into 0.5 milliseconds? So for this we are getting 0.3 millisecond. So this gives a T on and T off value. Okay, so from this we can get a duty cycle, that is duty cycle which is equal to 0.5 milliseconds divided by 0.5 plus 0.3 milliseconds. So this is 0.5 millisecond divided by 0.8 millisecond. So that we are getting for this 62.5. So we are designing here the Astable multivibrator which is greater than 70%. So we are this is greater than 50%. So we are getting a duty cycle value as a 62.5%. Okay, so this is one reading, and again we need to take 1/3 VCC and 2/3 VCC value. So for this we have to make it to ground and take one reference point here. Okay, so this is a reference point. I have made it to ground here. Okay, so we need to release that ground. Somewhat it is shifted. Okay, somewhat it is shifted. So if you look into the waveform, we can see from the ground point to here, this is 1/3 VCC. Okay, and from this to peak, okay, we can take this as a 2/3 VCC. Okay, so here first make it to ground. Okay, I am going to release that ground. So here we can see the shift of this. So this will be the 1/3 VCC. So what is a 1/3 VCC here is 1. Okay, 1 into, since it is a voltage, we need to take here voltage division. So 1 into 2 is 2 volt. So 1/3 VCC is 2 volt. Okay, so next we need to take 2/3. 2/3 means from the reference point here to this peak. Okay, so it is around 1.8. So 1.8 into 2 here. Okay, so we can write here 2/3, 1.8 into 2. So we are getting 2 8s are 16, 3.6 volt. So this is a value for 1/3 VCC and this is a value for 2/3 VCC. Okay. Finally, we need to calculate the frequency. So here frequency designed is 1 kilohertz. 1 kilohertz frequency. So what is the frequency from this means 1/T. Okay. So we can tell this as a T. What is T? T is T1 plus T2. T on plus T off. So T1 here is 0.5 and this one is 0.3. So this is 0.8 milliseconds. So 1/0.8 milliseconds we are getting. So for this we are getting the frequency as 125 hertz. But we have designed it for 1 kilohertz. Okay, and this is a required waveform and that is what we are getting here. Okay, that's about this. That's all about this Astable multivibrator where duty cycle which is greater than 50%. Okay.